Hi, welcome back to our next video on static indeterminacy of frames. We'll go through a few more examples in this session. Let's start with the first one. This frame, the number of members is equal to 4, the number of support reactions equal to 5, and then the number of joints equal to also 5. Okay. Then let's find the degree of static indeterminacy given by s equal to 3m plus or minus 3j. So you can use these three values here, okay, in order, but we also need to take into account the presence of these intermediates at these locations B, C, and D. Okay, each of them will offer one equation of condition, and hence 1 plus 1 plus 1 is equal to 3 should also be accounted for here, right? So we'll see that when you sum up all this, you'll get a value of minus 1. What does that mean? That means there are less number of unknowns and compared to the number of equations available to solve for them. Okay, so you get a underdetermined system of equations. Okay, which means that makes the system unstable. Fine, that's all. So that's all about the first problem. Let's move on to the second one. What about this problem? You can use the value of m equal to 4, r equal to 3, and j equal to 4. In this formula, it will tell that s is equal to 3. Okay, but does it mean only the static indeterminacy 3 and the particular, this particular frame is stable? Obviously, no. Why? Because we have these three reactive components which are parallel to each other, which means if I apply a load like this, which is perpendicular to the direction of this uh, direction where these reactions are parallel, this entire frame is going to undergo a rigid body motion this direction, right? So therefore, we can directly say this is unstable. However, if these three reactive components are replaced by a fixed support as we see here, then this s equal to 3 makes sense in a different manner. Let's see how. So what I'm going to do is I'm going to remove these three reactive components, okay? And instead of that, I'm going to just give one fixed support at this location at this joint A. Okay, then everything remains same, m equal to 4, r equal to 3, and then j equal to also 4. So if you use the same formula, here it gives a value of 3. Okay. And the previous video, I told that it's not always possible to clearly determine whether the indeterminacy is external or internal, but there are some cases where we can clearly tell. Okay, so perhaps in this case also we can seriously say that this indeterminacy is internal. Why? Because we see that these three reactive components are essential. Okay, so this is essential to make sure that the frame as such doesn't move as a rigid body. I mean to say, if this entire frame should not undergo a rigid body translation or rotation, these three reactive components are must. Okay, so there is no more argument about external indeterminacy. Fine. So what does that three mean then? That means we can see that there is a closed loop here, which means that we need to cut across the member, one of the members here. Okay. So when we do so, let's say I'm cutting across this member connecting joints C and D. If I do that, what will happen? I will be releasing three internal stress resultants such as shear force, bending moment, and axial force at this particular location. Okay, that's what this three means. So in this case, we can claim that this indeterminacy is internal. Fine. Yeah. Then this next one. So here we have a frame, okay, with a pin support and a roll support. We have pin support at A and a roll support at C. So as I don't know whether I told previously or not, even if I said it earlier, let me repeat. The correct way of approaching the problems of static indeterminacy is step number one. We need to ensure R is always greater than or equal to 3. If it is not satisfied, we can say the structure is unstable, right? R is greater than or equal to 3. Second step is, even if this is met, we need to make sure that the forces are neither concurrent nor, reactive forces or reactions are neither concurrent nor parallel. This also should be satisfied. Third step is, especially in case of trusses, we need to ensure that the members are appropriately arranged. Only if these three conditions are met, the stability requirement is met. Okay. Only then it is correct to check for the static indeterminacy. Okay. This applies to trusses, beams, and frames. So very first step is to check whether the particular structure is stable external as well as internally. Okay, externally as well as internally. Even in case of beams, I demonstrated a few cases where there were enough reactive components, so externally it was stable. However, because of the introduction of excessive internal hinges, there were possibilities of internal instability. Okay, so we need to rule out these two options. That is, the structure should not have external instability. The structure also should not have internal instability. Only then it's correct to apply the formula and see what happens. Okay, so in this case, we are not applying the formula as such directly. Just we are looking at the way the reactive components are arranged. We see that these reactive components will be concurrent. Yeah, correct. Here, yes, I thought it's parallel by mistake. Clearly, these reactive components are concurrent in this case. So, which means if I apply a load like this here, and then if I want to check the summation of moment equal to 0 about this point A or point C, it is obviously not met. Okay, all right. So, if I want to establish sigma of moment about this point A equal to 0, it is not obviously met because this force is there which gives a non-zero moment. Okay, so that makes what? That gives a tendency for this frame to rotate as a rigid body. Okay, so that's the problem, and hence it is unstable in this case. Right, and we have the fourth one here. In this case, just what I've done is I replace this pin support from the previous problem with a fixed support. What does that mean? Even in this case, you can see that these reactive components may be considered parallel, but does that mean it is unstable? No. Why? Because in the previous problem, I clearly told that if I apply a load like this and if I want to establish the moment equilibrium with respect to this joint or this joint, it can't be established, right? Because there will be one moment which is not equilibrated by any reactive component. However, in this case, what happens is if I replace this pin support with a fixed support, I have this reactive component MA. Okay, now if I want to establish summation of moment above the joint A equals 0, it is met. Why? Because this particular load will be there and also this reactive component will be there. Summation of that can be equal to 0. Okay, so MA ensures prevention of rigid body rotation in this case and hence it is stable. So this is stable. Then what is the next step? Yeah, now we can see what is the static indeterminacy. This straightforward here can directly apply the idea of open tree. If you allow this tree to stand on this fixed support, then the next step is to remove or release excessive reactive components. We have only this reactive component. We see that's what we need to remove. So directly I can say there is the static indeterminacy in this case is 1. Right? That's all about it. Then fifth problem, don't wonder that we have an arch here. I don't know whether it looks like an arch. It's locally, it's like this. Okay, consider it as an arch. But why did I include it here with the frames? The reason is even in case of arch, what happens is if you cut across any section, you find these three. Okay, there is going to be axial force, shear force, as well as bending moment. So it is appropriate to consider arch also as part of this static indeterminacy on frames. So that's the reason why I consider it here. Here then, what is the static indeterminacy? Static indeterminacy will be first we can check for the stability. We have four reactive components, so it is stable and they are neither concurrent nor parallel, right? Then static indeterminacy in this case will be SS equal to R minus 3, so 4 minus 3 equal to 1. Or you can think of this tree concept also. If you allow this arch to stand by this fixed support, then there is only one reactive component to be released, and that's the static indeterminacy only. That's all about it. Thank you so much for your passion listening. There is one more video which is coming up finally on static indeterminacy of frames. Don't miss out.